Hey guys, so this is Ayush here, and today marks day one of my series to basically do robotics by yourself. Like, the main motive behind this series is to learn and relearn, I would say. If I'm, if I have like spent the past year behind competitions, or let's say things like planning my future and everything like that. I was just busy in all of those things for the past 2 years. So this particular month, starting now, I want to focus on revisiting all of the fundamentals and just doing it all by myself, not being taught by a class or something like that. All I want to do is learn by myself through documentations, through maybe courses, basic courses, but not being entirely reliant on those courses as such as well, but exploring things on my own. All I want to do is have the knowledge of said packages, or in ROS, or let's say, or have the knowledge of the usage of certain, I would say, mathematical algorithms that might be required in AI/ML and other such fields. So that is my main motive behind this particular series. And today is day one. So today I want to decide a complete roadmap, and without wasting any more time, let's just get on with it. I will jot down a roadmap. I'll try to watch some videos, try to get some information on how I can do things in a way that will be very, very productive as well. In a less amount of time, I can get most of the things covered, and I can help this consistency be there for the rest of starting by a month and then going forward to a year, maybe till next June, July, where I'm here, where I'll be, wherever I'll be. So I just want to keep it consistent. Even if I go for competitions and all, I want to do something productive each and every day. So let's start with it. And I'll start by making something interesting, maybe like a timeline or something today, as it's day one. So day one, I just want to focus on making whatever's really, really significant and how I should plan the days forward, the 30 days that I have. So let's start with that. Here's my small notebook, or I would say diary, where I'll plan out everything, and by the end of it, I'll have a possible answer, possible solution by the end of this video, that whatever I'm doing is right or wrong, maybe. So, yeah, let's start. Also, yeah, big thank you before I start to like jot down my timeline. I wanted to be really grateful to everyone who has supported me. I just posted a small update on day zero, you can say, on Instagram yesterday, and the amount of support I got was overwhelming and amazing, to say the least. I would also like to thank Bhavesh, who has been like through the ups and downs that I've faced in the past 2 years, and yet he's willing to support me in my journey over here, be it anything multimedia related, or just as a friend too. So all of you, thank you so much, and I hope I will not let you down. And let's begin.
Whenever your heart is broken, don't ever forget you're golden. I will find the light in your soul, I'll be there. Never leaving you in the darkness, even when you're out of focus. I will be the light in your life, your secret.
So I'm halfway through the video which I was watching, and what I really discovered was that most of the things here are really, really, really beneficial to someone who's really starting out with robotics. So here are some key points that I felt that I want to share with people watching this video, and what going forward they can do with the problems that they might face, and the way they should approach their robotics learning, and how they can like just start with their robotics journey as it is right now, if they are listening to this video or watching this video in any time. So firstly, we cover 5 points according to the video that I watched. So the very first point was that you look at the problem, then you cover the solution, then you look at the framework at which, like, how, what are the really skills required that you need to I mean, get to the level at which you think you can be employed in a robotics company, or you can take up freelancing jobs in robotics. So what's the skill that you need, skill level you need to accomplish, or reach, and what is the action that you need to take. So firstly, what is the problem faced by many of the engineers or many of my fellow teammates, and myself included? What do I face over here? What is the problem here? The problem is we have an abundance of resources. Now going forward, we have chat gpt, we have books, we have Udemy courses, we have so many things. Like, that is a huge list of resources. We have even we've got blogs which feature technical knowledge these days. And like, a person gets confused where they should start when they are starting out in this field. So they usually don't want to get out of their comfort zone and explore at least one thing, because they have the fear of missing out on other things. At least that's what happened in my case, where I was just procrastinating because I was very like, scared, you can say, of exploring at one point of time. And as soon as I put my first step, then I knew that I had to eventually do everything, and then everything in the sense, the necessary things, and they'll be covered in one way or another if I make some intelligent choices. And even if I don't make some intelligent choices, if I mess up, I will learn from those mistakes. That's the number one thing. No one should be scared of making mistakes. So yeah, covering that, no starting point, no and like, it differs from individual to individual. Like, many people might like learning from Udemy courses. The other population, the other, you can say, spectrum of people might like learning from documentations or other things which are very very resourceful and very very accurate as well, and they are very nice, just to say the least. But the problem that comes is that people should identify which way works from them. It can't be like person A, who's my friend, let's say A is learning from Udemy, and so I should learn from Udemy as well, because he's going through the right path and he's doing well, so I should also do it that way. It could be that I, studying from documentation, I could do just as good as him, and I could learn things that he might not even have learned. So that's the main thing. You should identify what works for you. And then we move on to support system. Like, there is no one really that will guide you according to your needs. You will need to find that yourself. You'll need to be self dependent. And okay, moving on to the solution then. So what was the proposed solution in the videos that I watched? So the proposed solution was to firstly form a personalized roadmap to do these things, and moving on from that, you can just think about the learning framework. So the architecture that I noticed that the person who was teaching was following was that he thought up of three main things. So in the learning framework, he took up three things. So 2 points are mainly for absolute beginners or mediocre, intermediate beginners, and the third point would be for experienced, like people who are working in the robotics industry. So when you're starting out, when you're absolute beginners, you should be curiosity driven and you should explore. That's the main thing. So that's number one point. And the other point is that you should be really motivated, self motivated to do this every day, like I am trying to do right now. You should explore every single day. And the next point is domain driven exploration. So like, you can say there are multiple domains in the field of robotics. You can say mechanical, AI/ML, electronics programming, embedded programming, I mean, and so on and so forth. But you should have the knowledge as a beginner of these fields if you want to get into robotics. It's not that you can skip any of these branches. You even need mathematics, I would say, and a bit of physics, kinematics. Those are very essential for the fundamentals that you need for robotics. Moving on, we have progressive mastery. So that is the point he covered, and according to that, you should have a niche expertise on what you want to do. So like, let's say a person A has got really good with all the fundamentals, but now he should have a mastery at one particular skill that he has, so that the industry will have more value, add more value to him. So that's the phases of how you can go to the learn through the learning framework. Moving on, it's a 3-step process. Like I said, it's a process where you have skill development, you have project, and you have accountability. Now this is the most important part that I learned from many videos, and it's my personal experience as well. You do not need any sort of hardware. You do not need to buy anything. If you have a basic laptop, that's sufficient for this. That's it. You don't need anything else. You don't need to buy a robotics kit. You don't need to buy an Arduino. You don't need to buy an expensive laptop. You don't need to buy expensive hardware. Anything, like anything at all, because most of the work you can do on simulation itself. Like most of the learning can happen on simulations itself. That's it. And most of your questions can be answered there. Most of your mathematics applications can be answered in coding and simulations itself. There's no need to spend money in all of these things. And also the other point is that you don't need to spend excessive time in learning only. Like even if you have, like, I would say a month or 3 weeks or 4 weeks of fundamentals down, you're good to go. You're definitely good to go. As far as I have experienced, people who go and have a good grasp on their fundamentals for 2-3 weeks as well, they can easily implement most of the applications in robotics. And then if they want to go for a niche, for a proper like implementation, then yes, you might need the knowledge of a particular mathematics application. But other than that, in AIML also, but like other than that, no, you don't need to know spend years of training in that. So first we move to skill development. Now in skills overview, what I saw was that mainly people talk about the mathematics skills, the meta skills, the general software engineering skills, the programming skills, and the robotics tools that are required. All of these come under the robotic skills. So first we move to meta skills. What are meta skills? As a person, what you might need inside you. So meta skills are like curiosity, then problem solving, then lateral thinking, active learning, teamwork, persistence, communication, systems thinking. These are some of the keywords that I'm talking about. What do they signify? Like, if you have curiosity, you should practice asking questions. Like, if you're curious about something, you definitely should not shy away from asking dumb questions. Even you can ask those questions, but if you're redundant about it, yes, then it's not, there is no point. But like, if you really have do not understand a particular point, then yes, you should keep on asking it till the problem is solved in your head. Same for problem solving, you should start doing projects. For lateral thinking, you should brainstorm ideas daily. Like, think about ways in which people are not working right now and what could be beneficial to the market. Either let it be cost effective, or it could be something which is not cost effective, but it could be something new. So yeah, that. Next would be accountability. So if you're working in a team, and teamwork is a very important aspect, as I have discovered recently. You can't do everything alone. You can, definitely you can, but work just gets more efficient sometimes if you work in a team. Depends on the type of work and the type of leader you have. So you have to have, and the team as well. So if you have that accountability in you, that I have been given a certain role and you can perform that role to fruition, then yes, you have the meta skills required to become a good robotics engineer or a robotics person. Same with persistence. So you should be able to debug issues. Like you should be persistent till you are able to debug a particular issue in an application or something like that. The next part would be about presentation. So presentation is something very basic. Like you should have a particular way of presenting your idea so that no loophole is left in your idea while you're presenting it to an investor or something like that. So the way to communicate with people should be very crisp and clear. So that's one thing. Interdisciplinary projects. So again, this is one thing that is very very important. You should not have the mindset that okay, I am from the IT background, I can't do hardware, or I can't do mechanical engineering. So that's a completely lost notion. I have a friend, I have a teammate who does electronics, although he's from mechanical, and vice versa. He's also learning mechanical, although he has worked on electronics extensively. Same with me. I work on everything that I can find because I find everything interesting, and this month will display that for sure, because I want to show everybody that you can do it too. If I can do it, you can do it. So that's the main point of this particular series, that to make things possible, and I'll do it live so that the audience that is watching me might get motivated, might get inspired in a certain way to do it as well, and they'll get the guidance to do it the right way as I am learning over here. The next is mathematics skills. So in mathematics, you need algebra knowledge, you need kinematics knowledge, linear algebra, and you need, if you're doing machine learning, computer vision, and other things, sensor analysis, then you need statistics and probability of those things as well, because you're getting a cluster of data, right? You need to sort them out, you need to train them, you need to predict certain things, so those are also important. Then if you have let's say a robotic arm or something like that, then you need to be good with geometry, you need to be good with the manipulation of those robotic arms, you need to be good with inverse and forward kinematics, and lastly you need to be good with control theory, and the main reason being the symmetry and the robustness of your robot. If you want your robot to move without oscillations, without any noise, without disturbance, then you need those particular topics. Similarly, general software engineering tools. So let's say I am very good at everything, but there's one thing that's lacking, that's command shell scripting, pushing my code on Git, documenting them over there. Then as a systems engineer, I can't work on Ubuntu or something like that. So those things are very important. I need to have a good grasp on Git so that I can do version control system, or I'm good with Docker and cloud based things, or I'm good with operating systems and I can install multiple operating systems, identifying the differences between them, why certain versions of particular softwares are different from each other. Like let's take an example, some softwares work on Windows 7 while others only work on Windows 11, and why is that? So you'll have to be a good operating system um, curious engineer to know what exactly is going on the back end, or at least have an idea like, okay, what's the difference, this particular application can only work in this operating system. That knowledge is important as well. Shell scripting, like I said, then having cloud computing knowledge in AWS, Azure, and yeah, those are some of the important tools that you need. Lastly, I would say programming skills that you might need. So we have the mathematical skills down, we have the general software engineering tools down, we have the meta skills down of a person. Now we move on to the programming skills. So you need to have good knowledge in Python or C++, any of the two languages. You need to have good grasp in object oriented programming, and upon that you need to have good knowledge of an architecture of programs, how they are related to each other, how they are connecting to each other. Then yeah, after that, if you are designing front end GUIs, like you need to have good knowledge in that as well, like a little bit of web development, debugging, MATLAB might be important if you're not working on Python, and if you want to work on simulations and everything, then MATLAB is important. Yeah, that's about it. Lastly, we have robotics tools. So in robotics tools, we have robotics frameworks like ROS 2. They are very important as far as I've seen. Like, people underestimate the usage of ROS is a very very handy tool that you can use for robotics in this day and age. Once you're done with that, you can develop your own architecture, of course, but your own framework, I mean. And simulation tools like Gazebo are also very good, where you can take your robot and use the URDF to basically drive your robot in the simulation platform. Then data analysis tools like NumPy and pandas and all of those things that are used for I mean machine learning, so those are also very important. And even TensorFlow and PyTorch are important. So yeah, that's the crust of what I've done and what I've learned from the videos that I've watched. Another thing that is very very important is the skill stack now. So where do I learn these things from, right? So the videos even explained that, and I researched a bit as well. So calculus can only be done through calculus, right? Like, at the end you need to do it on your own. Similarly, Python, Git, ROS, problem solving, all of these things can be only done through practical experiences. So 2 hours, 1 hour of time daily put into these things can result, like, I would say, yes, 5 into 2, 5 into 1, 5 hours at least 7 hours you can give to all of this for development. Once you're done with that, every day for at least 2 weeks or till a month, I would say you have a good grasp on these skills that you have. And I'll practically show it, because even today I've worked on just the timeline for like 2 hours, 3 hours, and it's been a total ride, a complete revamp of my knowledge inside as well. So it's a good thing. So yeah, there are many platforms on YouTube itself, specific calculus related videos just for robotics. Python, Git, ROS, problem solving videos, all of them just related to robotics. And yeah, as far as I've reached, I'm there. And now next I want to move on the other part of the video. That's just halfway through the videos. I want to go further, and I'll speed through the next part as well, and I hope you enjoy the next part. Yep, see you then.
I'll be your inspiration, 'cause I know that you'll do just what you're told. I'll be your hard-earned temptation, 'cause I know that you'll make it on your own.
Yeah, so the final part of the video was very very interesting, and also pretty much it made me realize why I'm doing robotics and how like-minded people think about the same things. So to work upon that, I'll start covering with the second point, which is building the project. So the project pipeline should go in a way where it's defined in a very very systematic manner. So in your mind, you're clear about what you want to do. Firstly, you want to choose the project, then you want to break down the project into small modules or small different aspects which you can really focus on, subdivisions you can say. Then you'll need to define which concepts you need, and lastly you'll need to do the project activities. Like, let's say you know which concepts you need, and like you have done the research and you have learned all of the concepts, but now you need to implement those as well. So that's where this step comes in. So first step, so choosing the project can be anything, based from, it can be really anything, like taking a robotic arm, moving it, taking a robot and like moving it in the simulation, and making it autonomous of any kind, like from anything. So those are the kind of steps that I'm talking about. The choosing the project, it's all upon the level of expertise you already have in robotics, or the imagination that you have. Like, you really are limited by your own imagination, so you can think up of any problem statement. But accordingly, if the level of the problem statement and your level of understanding right now is tough, it will require a little more time, but it can surely be done, obviously, with your effort and time being invested in these projects. So breaking down the projects into some let's say points. So like the first step was to have a breakdown of the project. So first would be you set up the simulation environment. Let's say we don't have hardware, we don't need hardware. We firstly set up the simulation environment, and we do robot control in that. So we control the robot to either move or pick and place a robot, pick and place an object. So those are the like modules that you split your project into. Next you go and see what are the respective subdivisions, sub modules of these particular breakdowns. So like setting up a environment basically has importing the um, bins, the objects, the whole environment, the main robot with let's say it's a UR5 robotic arm, and like with that you have the end effector in mind. So all that is in the setup of the simulation environment. Then you have robot control. So in the robot control there will be joint control and the end effector control of the robotic arm, or the like locomotion control of the mobile robot. It can be anything like that. Picking an object can be defining the home position of that particular object, then reaching for the object and then grasping the object. Then placing the object can be reaching in the bin, second bin where you have to place it, releasing the object and returning to the home position for the robotic arm. I'm sorry, did I say home position of the object? I meant the home position of the robotic arm. So yeah, then after that you move forward with the like you know what you need to do now. You need to focus on the concepts. So let's define the concepts that you have for let's say the setting up of the environment. So that can be the transformation matrices and the robotic arm degrees of freedom that you might need. So those are the concepts that you need to know, like how is it a 6 DOF robotic arm, is it a 3 DOF robotic arm, and what are the transformation matrices that I might require for this particular robotic arm. Then the forward and inverse kinematics and the kinematic singularities for the control of the robot. Then of course differential kinematics and differential inverse kinematics for picking and placing of the picking of the object, and then placing can be done with trajectory planning, move it or something like that, which can plan your entire movement. So these are some of the concepts for an example that you can cover. It can be anything defined by you, and depending on that you'll make your own errors, and you'll have fun exploring the entire space of ROS, let's say. Or it can also happen in Windows. You just need to have specific Python created simulation environments. So it's all up to your imagination. You can do anything you want. The only thing is that you need to learn all of these concepts. You need to identify and learn these concepts. Next thing is accountability. Like I said, apart from kinematics and everything and all of these like academic concepts, all you need to be ready, willing to work in a team and expanding on your community, where you can learn a lot alongside other team members, and of course working together with them on particular projects as well. And yeah, this is about the starting point as I see on day one of my particular journey. And here I'm seeing that there are three particular steps that, like I covered, to summarize, which are um, firstly there is skill development, there is the project, and then there is project breakdown and project choosing of the project basically. Then there is accountability. So all of these three steps combined will let me have a start, and overall I have like 5 steps which will basically cover my process of becoming of building a roadmap. So this was my first step of realizing how I should go about a particular problem, and now I should just think about like how should I plan my year accordingly, year or month or weeks accordingly. So that's my next agenda, and this was Ayush Signegi on day one. I hope you enjoyed this particular video where I discussed a few points from my experience and what I'm thinking about right now. So thank you for joining me, and I'll see you guys in the next one, where I'll hopefully start something uh, interesting. So let's do that. Thank you. Please don't forget to like, share, subscribe, and post a few comments of feedback of how you thought the video was. And thank you very much again.